right. Hello, folks. And thanks for joining me again for another session of streaming. Um, just make sure that we are actually live and that I can hear what's going on. 1 second. Um, let's see here. All right, I think we're okay now. Okay, hello. All right. Okay, I think we're good. All right. So, again, thanks again for joining me. Um, so last time we left off at the point where we were able to build. So let me actually take a bit of a step back. So on the past few streams, we've been trying to essentially deploy Kubeflow, which is this toolkit for machine learning that runs on top of Kubernetes. And I've been having a little bit of trouble getting that deployed for various reasons, right? So we took a slight deviation. So one of the things that you're able to set up with Kubeflow are Jupyter notebook servers, and these these servers, they can either be the ones that are provided for you as part of your deployment, right? So they can be the ones that are essentially built in to Kubeflow, right? And it will have a lot of the packages and a lot of the things that that you're probably used to seeing with traditional machine learning environments, right? But the nice thing about Kubeflow is, again, because it's built on top of Kubernetes, it's supposed to be extensible and portable, so it relies a lot on containers, right? And what that means is, because we can use containers, and in this case, we're going to be using Docker containers, right? Because you can use containers, you can essentially build your own images and build your own, have your own sort of packages and different tooling that you might need for your machine learning workflows, containerized, right? And packaged into a container image. And the nice thing about that is we're not going to be working with .NET. We're not going to be working with traditional tools like Python and R. We're going to be working with .NET, right? We want to work with specifically, we might be working with F# in this particular scenario, right? Now, that doesn't come built in to Kubeflow. So what we're going to want to do is we're going to want to create a custom image that allows us to install things like Jupyter Notebook and the .NET kernel, which is known as .NET Interactive. We're going to want to install that onto this image, right? We're going to make it part of the image so that then we can just host this somewhere, whether it's Azure Container Instances or eventually where we're going to want to be hosting this, which is inside of Kubeflow, right? And we can just take this environment of ours, which is containerized, and we can literally anywhere that Docker runs, we can basically run our environment and get access to it, right? So last time where we left off was we were able to successfully, we took some of the bits or some of the build instructions from the .NET Interactive Dockerfile, which is it's basically what they use to host this image or this environment inside of what's it called, a Binder, which is this other tool that allows you to essentially host containerized environments in the cloud, right? Um, so they have this Docker. Hey Brett, how's it going? Thanks. Hope you're doing well as well. Thanks for joining. So so essentially, they on .NET Interactive, right? They have this Dockerfile. I can kind of show you. And I think last time we didn't really go through what the Dockerfile was doing. So I'm going to take a little bit of time to kind of go through it, right? So this Dockerfile, what I believe is used for on the .NET Interactive side is for setting up your binder environment. And again, as I mentioned, that's just this other way of hosting these containerized development environments, specifically Jupyter Notebook development environments, right? That are built or packaged as container images. Okay, so here what it's using is it's using the base Jupyter image, right? So that's the image or what it's working off of, right? So it's going to have all the Jupyter Notebook dependencies installed. It sets a few variables, right? Environment variables as well as just variables themselves. And then it just runs a few commands, right? In this case, I believe I'm gonna say that the Jupyter base image is a Docker base image, right? Because you're using apt-get, which is the package manager, if you will, for Unix type environments, Linux specifically, right? Set up a few more environments, right? Regarding telemetry and all those things. Install some dependencies, right? So anytime you say run, essentially it's almost like you are running the command in the command line or command prompt, right? And here, again, because this is all starting from scratch, right? We have to install all these things. And in this case, what we're installing is the .NET SDK version 3.1, right? So this uses the latest version of the .NET SDK. In this case, we don't need this. So there are a few sample notebooks in part of this directory that we don't need, and we don't need any config files for NuGet because we're not going to be working with the same dependencies that this particular project works with. All right. Then this image installs Interact, and Interact is just a different sort of UI for Jupyter Notebooks. So there's the traditional web. There's different ways to interact with Jupyter Notebooks, right? So you have the standard Jupyter Notebooks interface, which is what we were trying to deploy last time. You have Jupyter Lab, right, which is a little bit a bit more robust. You have it's just a different way of interfacing with it, right? Some people prefer that, right? And then Interact, which I believe is built on top of React, right? So it's a little bit more modern. It's a little bit nicer UI. It's installed here as part of it, right? And .NET, the .NET kernel and Jupyter Notebooks for .NET work with Interact, right? And just to kind of give you a sense of what that looks like. Interact, Jupyter Notebook, right? Interesting. .io. Yep, there you go. And it seems like they even have like I'm gonna assume that this might be running on Electron, right? That's how you can get this cross-platform feel to it. And again, because it's a web-based tool, you can essentially work with this if you want, right? And I think, yeah, I think you might be able to do even more things. It's not just being able to have a different UI associated with it, right? Okay, so that's exactly what's happening here, right? So it's installing Interact for Jupyter Notebooks. And then here's where it's the important part. So now that we have all of our dependencies installed and all of our, any libraries that we might need, then we go ahead and we install .NET Interactive. And .NET Interactive, again, it's it's the kernel, right, for .NET Jupyter Notebooks. And I wonder if I can kind of show you how it works, right, to give you a sense of an idea of what I'm talking about when I'm referring to a kernel. So let me see if there's good documentation here. So this isn't It's not great, but actually, this is a really nice way to think about it if you were to diagram this in terms of the architecture, right? So Jupyter notebooks have this notebook document format, and it actually looks very much like JSON. So the extension for Jupyter notebooks, it's IPyNB, and it doesn't matter what language, right? So Jupyter notebook supports, I think, over 40 languages, right? That and for building and working with these interactive computing environments, right? So it has over 40 languages. Now, the extension is IPyNB, and the document format, it's it's basically just JSON, right? It really is. And what the kernel is, it's just a process that's sort of running in the background, and the process runs in whatever language it is that you want to interpret, right? So it's just running in the background, right? And what it's doing is it's just taking input, right? Whatever code or whatever you're entering into the Jupyter notebook, and it's just interpreting it, right? It's just taking the input, parsing it, interpreting it, and returning the output of that, if any, right? And the way that it can communicate is with this interactive computing protocol, which is based on 0MQ, right? So the messaging, that messaging protocol, right, with 0MQ, that's essentially what it's based off of. So whenever you know, input something on the notebook side of things, right, and the notebook, again, it's JSON, but the browser and whatever UI you're using, whether it's Jupyter Lab, Jupyter Notebooks, Interact, right, they know how to parse that and display it nicely, right? But whatever you're entering into this interactive environment inside of your Jupyter Notebook, right, it gets sent via the interactive computing protocol to the kernel. The kernel, which is running in the background, interprets that interprets that input, and then produces an output. And then using the interactive computing protocol, it sends the message back or the output back to the notebook, right? And then the notebook renders that. Right, so that's essentially how these things work. So when I'm referring to .NET Interactive and the .NET kernel, that's exactly what it is, right? In .NET Interactive, you can do C#, F#, and PowerShell, right? So it's essentially just running this background process that's interpreting these languages, right? And that's exactly how it works. If you want to write your own kernel and say, I don't know, Elixir, is Elixir a language? I don't know. But yeah, so essentially any other language you want to write, if you wanted to write an OCaml, which I believe there is an OCaml kernel for it, right? You're more than welcome to, as long as you're able to basically parse the messages coming in from 0MQ and send back the output. You can literally interpret whatever, right? So that's kind of how that works, and that's what .NET Interactive gives us, right? It gives us that .NET, C#, F#, and PowerShell ability to interpret those languages, and then again a few other environment setup, right? And that's basically it. So that's essentially what this is doing. Okay. So last time we left off at the point where we were able to build this image, right? So let me actually log into the to my local computer here that I have. I hope it's still running. There we go. Okay, perfect. So on this computer, we have I don't know why it's super slow. It was happening last stream too, and it seems like OBS is not the one that's taking up. I think it's other resources that I have on my computer that are taking up a lot of the resources that I have here. But anyway, so on this computer, I have Docker installed, right? So if I do docker image ls, whoops. image ls, we should be able to see, right, 47 hours ago, 2 days ago, we built this .NET Interactive image. Okay, and if I open Visual Studio Code, let's see here, and I SSH into that VM, we should be able to see what the image we used looks like. And again, it's not going to be very different from what we from what the .NET Interactive image looks like. So to start off, I just want to make sure, I just want to get this environment working, right? I want to get it working, and once we're able to access it from our computer, even though it's hosted remotely, and we're able to access it, what I want to then start doing is I want to start adding other things, right? There's other .NET packages and libraries and tools that I like to be able to use as part of this development environment. So let's open this in the window. Okay. In the meantime, while this is loading, how are you folks week? How's your week going? It's Wednesday, or at least it is Wednesday here. And yeah, so made it halfway through the week. So what we can see here is the image looks exactly the same as that. The only difference is this, and the reason why it's set up this way is because Qflow has some specifications that this is what they want. This is what they want you to this is what they want you to have at the end of the image, right? So you can have whatever in the setup, but when it comes time to run your image, this is what it wants you to run, right? So that's why this is there. So that's probably the only part that's a little bit different here. Let's see. Now, last time we were having trouble deploying this, and the reason we were having trouble was because, well, actually, I don't know. So that's what we're trying to figure out today. Why can't we access this this image, right? So Docker, let's see. Docker run P8888. And what was it called again? lqdev.net interactive latest. And I want to run the latest version of this image, right? So I don't expect this to work. And the reason is because, well, let's try it. And we'll see if it works. So right now, I'm not publicly exposing this, right? So it tells me, hey, go to this thing. But again, I can only access this locally, right? If I try to access it from this particular, from this browser, right, it won't work. There you go, right? It can't, because it's like, I don't know what you're talking about, right? So we need some way to access this, right? So one of the things that we can do is we can set up tunneling, right? So let me start up a new one, right? So SSH, and then I want to bind port 8888, localhost 8888. Okay. So essentially, I'm telling it, hey, this is the port locally that I want to bind to, and this is the port that my application is running in my remote host, and log into that, right? So set up a tunnel. Okay, so this is set up. So now, ideally, I should be able to go to localhost 8888 here, and it should work, but it's not, and I don't know why. Let's see. What if I do? Oh, whoops. Yeah, that's not gonna work. Yeah, I can't. Yep, it can't connect to it. Why is that? Actually, I think I know why it might be. So in the image that we set up, right, we're not listening at localhost. We're listening at whatever the name of it is. And when I set this up here, right, I told it, hey, it's listening on localhost, which it's not. So let me try this. SSH-L 8888 0000 8888 qdev. Okay. Oh, that's why. Okay. 0000. Let's see if this will work. All right, let's try this again. Whoops. 8888. Connection refused. Why? Yeah, so it can't go to localhost. It can't. I wonder if I have to tell it to expose the port. So, let's see. So if I go back here, let me stop this, okay? I wonder if I have to tell it expose here. Expose 8888. And what this will do is it's going to allow this port to be open, right? So where's Docker? Docker. Where's the docs? Docs. There we go. Oh, but I might have to rebuild my image if I'm doing this. Reference. Build images, Dockerfile best practices, build kit, nope, manage images from your app in production, open source to Docker. Okay, scale your app with Kubernetes, volumes, mind mounts, general application development practices. Yeah, I'm not looking for this though. I'm looking for, maybe I'll just look at the reference. Okay, Dockerfile. Okay, so there's the run. Where's expose? Expose. There it is. Okay. So expose. Instruction informs Docker that the container listens to a specific network at runtime. You can specify whether the port listens to TCP, UDP, at default, TCP. Okay, expose does not actually publish the port. It functions as a type of documentation between the person who builds the image and the person who runs the container. Okay. Okay, fine. So let's leave this as is. Let's see. 8. Okay, so this is happening. I doubt that this is gonna work, but worth a shot. Yeah, that makes sense. Now, if we go back here and we try the same thing, all right, let's try this. That worked? Yes, that worked. Okay, awesome. So how we got that to work was, and I don't know why. Okay, let's go back to the docs and see what the difference is. So did I lose it? No, Docker reference. Okay. Okay. Let's see. Use P with Docker run. The port will be exposed once for CTP and once for reader. That P uses an ephemeral higher order post, so the port will not be the same as TCP. So essentially, you can override them at runtime by using the PFLAG. Okay, which is what I did, right? I set it up as at runtime. To set up port redirection of the host system, the Docker network command supports creating networks for communicating among containers without need to expose or publish specific port because the container is connected to the network. Okay, this is not exactly something we care about, but what I want to know is what was the difference between what I did, right? Which was just I told it dash P80, or in our case it was P dash P8888, and then dash P8888 colon 8888. I'm not sure. I'm really not sure, but it seems to have worked for our case, right? Or for our purposes, right? So now we are in Jupyter, right? And if I were to say, there we go. See, nice. So now we have Python, right? Which is kind of what's something that's built in already, right? The Python kernel already comes with it. But we also get the .NET Interactive kernel, right? Which is the C#, F#, and PowerShell kernels, right? So in this case, let's go ahead and try it F# because I like working with F#. Oh no, there was an error. New F#. Okay. Seems to not have liked that. Let's go back and see what happens here. Permission denied. Interesting. Okay. Let's shut this down for now. And one thing that I might want to do is let me not do this. All right, let's just work with the base image. Docker build -t. And what are we gonna build? qdev slash, what do I call it again? Docker image ls. Okay, Docker image. It's gonna be Docker build -t qdev .NET interactive latest. Interactive latest. And in the file, it's called .NET. Oh, it's in. Okay. Boom. All right. Is that it? Oh, I didn't save it. So when I save this, I should get the latest changes. Awesome. Docker image ls. Docker image remove. Well, what am I removing? I'm gonna remove this one, right? No. Okay, so this is one of the things that I hate. I hate having to purge. I think that there's a command called rm. Let's see, compose. No, not compose. Command line reference. Docker CLI Docker. Docker run. Where's run? There we go. Run. So when you have the run command, there's this flag or option that you can pass in, and I was lazy and I wasn't doing it. But if I think it's called rm. There we go. --rm. Automatically remove the container when it exits. Yeah. Right. So because we didn't do that, you see that there's this sort of like ghost, or this container that's just like randomly there, right? So what we want to do is we want to go ahead and we want to remove that, okay? Because we're not working. Now, the reason why it's not letting us remove it is because we exited this process, and there's some sort of process in the background that's sort of like ghost, and it's just like it's a zombie, what do you call it, like process that's just out there running. And this image is tied to that process, so it's like, hey, there's a process using me, I can't remove myself. So let's check out what is going on. Docker ps. All right. Docker ps. Okay, so there's nothing here, right? But if you do docker ps-a, there's all that, right? Now, I believe that there are, what's it called? There's a command, I think it's called docker purge, which should remove docker ps purge. And that should remove them all rather than going one by one. I mean, purge. Is there nothing with purge here? Docker container top, unpause, stats, run, remove. Docker. remove all stop containers. Yeah, we can try this. Yep, remove all stop containers. So I think this... Yeah, this works. So now if we do docker ps-a, there we go. That's gone. And docker image ls, docker image ls. That one's still there, but now we should be able to do docker remove. And we can tell it, hey, this image here, let's get rid of that. All right, I guess that doesn't work. I think it needs to be more. Yeah, you can't just... I think it's the first 7 that you need to pass in. That's weird. All right. Let's see here. Docker remove, force remove a running container. That's not what I want. I mean, I could see it here. Docker. Is it image remove? Oh, there we go. So it's the Docker image remove. Docker RM, I guess, is just for the containers. Docker image remove. That removes the actual image. Okay, fair enough. If we do image ls, beautiful. Okay, so now that we have this, let's try to run it again. So docker image run --rm -p, right? 8888 .NET interactive. Whoops, that's not it. Dev .NET. Okay. Nope, it's just Docker run, not... Okay. Awesome. So now, if I were to go here, all right, it's gonna ask me to log in, but I know what my token is. So okay. So now we're running, and what we did there was so when you run this command, you run without any authentication, right? And this is okay in Qflow, and the reason for it is Qflow handles the authentication for you, right? But in this case, what I care about, but in this case, we're not running on Qflow yet. So let's go back to using authentication, because I think that may have been one of the reasons why it wasn't working as it should. Well, let's see. Error creating while creating. Okay, I'm still running into the issue. Let's see. Let's see if we can debug what's going on here. So new, go ahead and clear out my network. F#. Okay, contents. Forbidden. Okay, so it's telling me that I'm forbidden, even though I gave it 1213. Even though I gave it, okay, interesting. I wonder what happened. Well, let's see. Maybe it's still like, let me try a hard refresh. If I go to new, F sharp, still running into the issue. Okay. Huh. I wonder if I stop this. Let's see, Docker ps dash a. Yeah, beautiful. So it took place, right? So let's see here. Docker rm. No, I want a Docker run. But I want to try to do this